Objectives of structural designer. Design is a process by which an optimum solution is obtained by satisfying certain criteria. Minimum cost, minimum weight, minimum construction time, minimum labor, maximum efficiency of operation. You can, while keeping these points, you can see your client's requirements, like you are going to design some member with minimum cost, minimum weight, lightweight, minimum construction time, okay, minimum labor, and maximum efficiency of operation. Means for the good intended life of that structure. That is the objectives of the structural designer. Objectives of structural designer: the must learn to arrange and proportion the parts of structure so that they can be practically erected and will have sufficient strength and reasonable economy. For example, structural designer design the member, but that steel section not available in the market. So there will be a lot of difficulty in the arranging of members. So it is the structural design responsibility. He should have a market survey, okay, so that the members should be connected well, okay, and the member can give the sufficient strength and reasonable economy. These important items called safety, cost, and practicability are discussed next. So that is the practicality that is very important. That comes with the experience. Objectives of designer. The structure must safely support the loads to which it is subjected. So whatever member you design, it can bear the loads safely. So that is the first objective. The deflections and vibrations should not be so excessive as to frighten the occupants. For example, you have designed the steel member, it has sufficient strength, but that has so much ductile that giving the large deformation. The occupants or the residents in the building, they may think that the member are going to collapse, but it has sufficient strength. So that is not a good thing. So the deflection and the vibration should be within the limits, or you can say the serviceability limit criteria. The designer must keep the construction, operation, and maintenance cost at the lowest levels without sacrificing the strength. Okay, so whatsoever material, for example, if you are going for design of steel structure, so you must recommend the protection criteria, so that the future maintenance cost, all these types of expenses, the client may save the cost. Designer need to understand the fabrication methods and should try to fit their work to the available fabrication facilities, available materials, and the general construction practices. For example, the steel structures are connected by different methods, like they can be riveted, bolted, and welding. And one person, he never saw what is riveted, so how the designer can understand and design the structure in the fabrication. So the structural designer must have the knowledge what is the fabrication methods, how the members will be joined with the riveted, welded, and bolted in the steel structures. Some designers lack in this very important aspect, and their design cause problems during fabrication and erection due to the lack of fabrication knowledge. Designer should learn everything possible about the detailing. For example, after the design of steel structure, you have to sketch that member on the drawings. So the designer must have the good understanding of the detailing, the fabrication and the field erection of steel, besides the loads, mechanics, and the expected material strengths. So all these things, the knowledge of these things should be well with the structural designer. The designer must have information concerning the transportation of the material to the site, labor, conditions, equipment for erections. That should be with the knowledge of all these things with the structural designer. Problems at site, field tolerance, and required clearances at the site. For example, there is no hindrance, field is okay, problems at site, what the problems can come, the structural designer should also have the knowledge of these things. This knowledge helps to produce reasonable, practical, and economical design. This is the you can say the theme of this objectives of structural designer. All the points. This all the knowledge will helps to produce reasonable, practical, and economical designs. Structural design procedure. That are the basic steps for the structural design procedure. First of all, we collect and list all the known data, like what is the span of beam, what is the loading, okay, dead load, live load, okay, all these we get from collect all the data, and then we will select a trial section. Definitely, first of all, we make a trial like this much of cross section will be okay for this. If the member goes for the failure, then we revise the section with the higher dimensions and the higher strength of the material. We repeat this process. After satisfying these checks on the trial section, we apply the stability check, okay, and then we will perform the strength checks. What are the stability checks? In the steel section, there is most the phenomena of one failure, that is the buckling. In their flange, their web, they got locally buckle. So we have to also perform the stability checks. Then the perform strength checks, that are the material strength, means applied loading should be less than from the material strength. Then the perform serviceability checks, means deflection should be within the limits control. Accept section if all these checks are okay. If the trial section, then we perform these checks. First of all, I have just explained in the theory. So here are one by one checks. Then if all checks are passed, we will accept that section. If this all checks are failed, then we will go up again, select another trial section and perform all these checks. And after, if the all checks are okay, then we will write the final design section. So that is the structural design procedure. Limit state. Limit state is defined as I have already explained. I will explain it here also. Limit state is defined as the stage in the loading after which the structure cannot fulfill its intended function due to strength and serviceability considerations. Means if limit state, that is the strength criteria and the deflection criteria or the serviceability criteria. If anything goes beyond the strength criteria or the serviceability criteria, the member will go for failure. The term limit state is preferred compared with the failure, because in most cases of limit state, the actual failure or collapse does not occur. What it means, we design our member within the elastic range, and when the member reaches its yield strength, we say that the member is gone for failure. But it does not mean the member actually fail. Member have a reserve strength. So that is the limit state is preferred compared with the failure. We say when the member reaches to yield strength, the member is going to fail, but it still have the strength, or you can say the reserve strength. Limit states are generally divided into two categories, that is strength and serviceability. So strength or the safety limit state means the condition of loading corresponding to a maximum ductile flexural strength, for example plastic strength, ultimate ductile shear, ultimate ductile shear strength, buckling, fatigue, fracture, overturning and sliding. All the forces which can fail the member in strength criteria, that is the strength limit state. And serviceability limit states are those concerned with the occupancy of the building, such as deflection, vibration, permanent deformation or cracking. All related with the deformations are serviceability limit states. Limit state. The structure should not cross any strength or serviceability limit for a perfect design. All the applicable limits are to be checked by using the available procedures that are given in the codes, and we will also perform during the design.